just you're given the nested list of integers nested lists. Each element is either an integer or a list. So each element in the list is either integer or a list, whose elements may be integer or other list. Implement the iterator to flatten it. So we have to store all the elements by flatten it. What it means. Nested list iterator initializes the iterator with a nested list named nested list. In next returns the next integer, and has next returns the true if some integers in nested list, otherwise it returns false. So like what can we do about it is that like if there's a list name this, so I'll just shorten it and place it here now that we've read our question. So if this, so just come to the illustration part. If there's a list 1 comma, there's a list, another list 3 comma 7 and 8. So we can assume it like we get 1 and then we go down. So it's 3 and 7 and there's 8. And if 7 was a list as well, then by insert then we should remove it and we go one down more deep. So it can be assumed as recursion, and the recursion tree formed here shows that how we can do this. So in order to flatten it, we just count for 1, then we go to 3, then we go to 7, then we return back to 3, then we return back to 1, and we come to 8. That was the third element of the like outermost list. So firstly we'll go and append 1, then we move like sorry like it's 4 indexed 4, so it would make more sense if I can like rotate it somewhat like this, but don't mind them actually. Oh, I'll rename them as 1 2 3 4. This is 1, this is 2, this is 3, this is 4. So first we're going to enter 1 and then we'll go one step deep and we'll be entering 3, and from 3 we go one step more deep to 7, and then we will come 2 step out and put 8, and at the end like the first one we achieved was 1, so we can either like reverse this stack or we can count one by one, appending one by one in a separate test like this. So let's just implement, and we have to use the 3 functions that are mentioned like this: is integer, and get list. So yeah, like we can go ahead. Self dot res equals to array, self dot pose equals to -1 because you're going to start from 0. Self dot flatten list equals to okay, self dot flatten list equals to nested list, and let's just write the function flatten list here. Def flatten the recursion part which is going to happen here. Self dot nested list, and here what we are going to do, here we are going to iterate for I in nested list if I is integer, then we are going to we are just going to append it into self.res. Yes, self.res.append, and for that also I think we have to use some of the function, I guess. Get list, get integer, yeah, get integer we have to use. Append, but like we have to use get integer, but like okay, so should be the get integer. Like we have to execute this function on I, else self dot flatten, and going one step deep. This is where recursion is implemented and how the tree pattern works. Flatten list, get list. All right, we are good until now. And to check next, what we are going to do is we are going to just write self dot pose plus one and return whatever the value of self dot in uh, self dot res, and here we will pass self dot post, so which is the current position, and has next return length of uh, self. Okay, instead of doing that we can do self dot pose plus one is less than length of self dot res. So by this means we can confirm if we are like in a position where we can check for all the elements of result that are stored. So let's just submit it and check if it is run. So runtime error, no attribute flatten list. Okay, flatten list, camel case, nested list. Why is there nothing? Okay, again, silly mistake. Guess I'm making a lot of them today. Yeah, so it's accepted now. So it was pretty easy and like efficient as well.